Hello, ladies and gentlemen, and welcome to the notes for section 10.1, part A. In this chapter, chapter 10, we're going to be covering square roots. We're going to be beating them to death, or really not beating them to death, but we are going to be digging fairly deep into them, much deeper than you have in the past. So if you're not a big fan of square roots, don't worry, it's going to be okay. And if you are a big fan of square roots, it is your lucky day because we are going to get so many square roots. But before we get into square roots of x, let's look back at x squared. Okay, you'll notice here we have our parabola, which tells us right away that we have an x squared term in our equation. And if you look over here, we certainly have that. And in fact, y equals a times the quantity x minus h squared plus k should look really familiar to us. Tell me what it is. Correct, I hope. It is vertex form of a parabola or vertex form of a quadratic function. So we're going to take that vertex form and we're going to change it just a little bit because the vertex is so helpful for us graphing wise that it's actually going to help us with our new equation. So instead of squaring it, I'm going to take this to the 1/2 power. Now, take a moment, look at this graph, but also tell me, what does it mean to take something to the 1/2 power? Okay, if you remember, taking something to the 1/2 power is the same as taking something, taking the square root of something. And if that doesn't sound familiar, look back at section 7.3, and that's where we dealt with rational exponents. That's what I'm trying to say. So take a look back at 7.3 if that's confusing you. But when I take this y equals a times x minus h to the 1/2 power plus k, that is essentially our square root function. So the way I'm actually going to write this is y equals a, that's c, a times the square root of x minus h plus k. And you'll notice how my blue line disappeared, and that's because this black line is the same thing. So just kind of proving that the 1/2 power is the same as taking the square root. Okay, so that is the meat of what it is we're going to be looking at. We would call this a radical function, or we could also call it an square root function. A lot of people will call it that. And for our intents and purposes in this class, that should be okay. We're not going to get so nitpicky. We're certainly not going to be dealing with anything like a cubed root or any other nth root. We'll only be dealing with square roots. So if you guys start calling this the square root function, that's fine. But its technical name, the name the book is going to use, is a radical function. Now, we're going to talk a little bit more about the shape of this graph in part 2, but for right now, I really just want to focus on what it would take to actually graph it. Now, the way we've graphed so far is we plug the equation into the y equals feature on our calculators, find the points, plot the points, and that's exactly what we're going to do. We're going to plug it into the y equals, use the table to find points, and plot those points. You can do it on Desmos, but it's not as nice. I mean, what I really could do is I can just drag my dot, and there I found 4,2. I know what I'm doing, so I also know that 9,3 is going to be a nice even point. But if you don't really know what you're doing, Desmos does not do as good a job making those tables as your calculator will. So I'll recommend stick to the calculator, type it into y equals, go to the table, find the points, and plot the points that make the most sense to plot. That part, I don't want to call it easy, but we should be at least comfortable with it, or as comfortable as we're going to get with it between here and the end of the year. But what is going to be different is you will still be asked to name the domain and range. Domain and range does take a little bit of a change because if you'll remember, the domain for all quadratic equations was going to be all real numbers. I told you guys that if you got nothing else right on your quizzes and tests, you would at least know that in chapter 9 the domain was all real numbers. But if we think about what the domain is, which is the possible x values, how far left and how far right the graph can go, this one can go on forever to the right. Okay, I can keep going and going and nothing's going to change. It's going to keep getting bigger and bigger. But to the left, it stops. It stops at 0. And so we would say that the domain for this graph is all numbers such that x is greater than or equal to 0. Now, I'm going to play around here a little bit with the shape of this graph, But if I take this h value, which if you remember from vertex form of the quadratic, h was the x coordinate of the vertex, we don't really have a vertex anymore, but if we were to take that h value and make it negative, you'll notice that my graph, moves left, and if I make it positive, it moves right. So ultimately, if I have it here at x equals -4, my domain now becomes x is greater than or equal to -4. Okay, all the values greater than -4 work, but anything less than that is not going to work. So what I end up with ultimately is that my domain is all numbers x greater than or equal to h. Okay, and take a moment here to answer this question. Okay, good thinking. Now, with range, this is actually the same way that it worked in the previous chapter, right? We look at that vertex point, and again, it's not technically a vertex, but it's close enough to a vertex that we can refer to it as that. We look at that point, and the value that k is here is the lowest value it's going to be. And I can make k bigger, I can make k smaller, but ultimately my graph is not going anywhere below k. So that means that my range will be y is greater than or equal to k. So as a final review, and let's go back to our home screen where everything's looking hunky-dory. Make that 0 and make that 0 as well. We have y equals a times the square root of x minus h plus k. We're going to call that vertex form of a radical equation. We have the domain is x is greater than or equal to whatever h is. We have the range is greater than or equal to whatever k is. And we've also kind of already hinted at the fact that h and k and a are going to change the way the graph looks. That's what we'll talk about in the next part. But for right now, these are the three things we need. This form, this domain, this range, and have in the back of your head that there will be times when these two things might be less than or equal to instead of greater than or equal to. Okay? Take a break from this one, watch it again if you need to, and then move on to 10.1b. Thank you.